Beneath the surface of our vast oceans lies a world of mystery and wonder. It's a realm that has captivated human imagination for centuries, yet much of it remains unexplored. The depths of our seas hold secrets that we're only beginning to uncover. And in this quest for knowledge, we've found unlikely allies: underwater robots. These mechanical marvels are revolutionizing ocean exploration. They go where humans cannot. They dive deeper, stay longer, and withstand pressures that would crush a submarine. Underwater robots are our eyes and hands in the abyss. They're helping us map the ocean floor, discover new species, and understand marine ecosystems. These robots come in various shapes and sizes, each designed for specific tasks and environments. Some are tethered to ships, controlled by operators on the surface, while others roam freely, guided by sophisticated onboard computers. From inspecting underwater pipelines to studying the effects of climate change on marine life, underwater robots are at the forefront of oceanic discovery. They're helping us understand our blue planet in ways we never could before. Remotely operated vehicles, or ROVs, are underwater robots from the 1960s. Think of them as underwater drones. They're connected to a surface ship by a cable. This tether supplies power and control. It also transmits data and video feeds. ROVs come in all sizes. Some are as small as a shoebox, others are as large as a car. The size depends on their purpose. Smaller ROVs inspect ship hulls. Larger ones handle heavy-duty tasks. They repair oil rigs or recover sunken objects. ROVs are incredibly versatile. They can be equipped with various tools and sensors. They stay underwater for long periods. Unlike divers, they don't need to surface. This allows for extended work periods. ROVs can dive over 6,000 meters deep. While ROVs are tethered to ships, autonomous underwater vehicles, AUVs, are free-roaming robots. They're like the Mars rovers of the ocean. AUVs are pre-programmed to carry out specific missions. Once launched, they operate independently without constant human control. This makes them ideal for long-range exploration and data collection. AUVs come in various shapes, but many are torpedo-shaped for efficient movement through water. They're equipped with their own power source, usually rechargeable batteries. This allows them to operate for hours or even days at a time. AUVs are packed with sensors and scientific instruments. They can measure water temperature, salinity, and chemical composition. Some carry sonar equipment for mapping the seafloor. One of the biggest advantages of AUVs is their ability to cover large areas, creating detailed maps of the ocean floor. AUVs have been used to map coral reefs, track ocean currents, and even search for sunken ships and planes. They've been used to explore under Arctic ice sheets and in deep ocean trenches. The field of underwater robotics is constantly evolving. New technologies are making these robots smarter, more efficient, and more capable. One area of innovation is in materials science. Engineers are developing new materials that can withstand extreme pressures and temperatures. This allows robots to dive deeper and explore more hostile environments. Artificial intelligence is another frontier in underwater robotics. AI algorithms are making AUVs more autonomous. They can make decisions on the fly, adjusting their missions based on what they encounter. Some can even identify and classify marine life automatically. Power systems are also improving. New battery technologies are extending the range and duration of underwater missions. Some researchers are even experimenting with underwater charging stations. Communication is a major challenge underwater. Engineers are developing new ways for underwater robots to communicate, using acoustic signals or optical communication with lasers. These advancements could allow for real-time data transmission from the depths of the ocean. The discovery and exploration of the RMS Titanic wreck is one of the most famous uses of underwater robotics. The Titanic sank in 1912, but its exact location remained a mystery for decades. It wasn't until 1985 that the wreck was finally found, and underwater robots played a crucial role in this discovery. The initial discovery was made using a towed underwater vehicle equipped with sonar, but it was ROVs that allowed for detailed exploration of the wreck. These robots provided the first clear images of the Titanic since it sank. They revealed the extent of the damage and the ship's condition after decades on the ocean floor. Since then, underwater robots have been used extensively to study the Titanic, mapping the debris field, recovering artifacts, and monitoring the wreck's deterioration. The exploration of the Titanic has driven technological advancements, benefiting underwater exploration beyond just the Titanic site. The need for high-quality imaging in deep, dark waters led to improvements in underwater camera systems and more precise control systems for ROVs. Hydrothermal vents are one of the most extreme environments on Earth. They're found in the deep ocean where tectonic plates meet. These vents spew superheated, mineral-rich water. The discovery of these vents in the 1970s revolutionized our understanding of life. Underwater robots have been crucial in studying them. ROVs and AUVs allow scientists to observe and sample vents up close. These environments are too hostile for human divers. The water can reach over 400 degrees Celsius. The pressure is crushing, but robots can withstand it. Robots have mapped vents, collected samples, and filmed bizarre life forms. Exploring the deep ocean presents numerous challenges, and designing robots to work in this environment is no easy task. One of the biggest challenges is pressure. At great depths, the pressure can be hundreds of times greater than at the surface. This can crush conventional equipment. Engineers must design hulls and components that can withstand these extreme pressures. Another challenge is communication. As mentioned earlier, radio waves don't travel well through water. This makes it difficult to control robots or receive data from them. Tethered ROVs solve this problem with their cable connection, but for AUVs, alternative methods are needed. Acoustic communication is often used, but it's slow and limited in range. Navigation is also tricky underwater. GPS doesn't work beneath the waves. So underwater robots need to use other methods to know their location, like inertial navigation systems or acoustic beacons. Improving navigation accuracy is an ongoing area of research in underwater robotics. The future of underwater robotics is exciting and full of potential. One area of development is in swarm robotics. This involves using multiple small robots that work together as a team. Swarms could cover large areas more efficiently than a single large robot. If one robot fails, the others can continue the mission. Engineers are taking inspiration from marine animals to design more efficient underwater robots. Some robots mimic the movement of fish or jellyfish. Artificial intelligence will play an increasingly important role in underwater robotics. Future AUVs might be able to make complex decisions on their own, adapting their missions based on what they discover. Underwater robots are becoming increasingly important in marine conservation efforts. They're helping scientists monitor the health of ocean ecosystems. Robots can survey coral reefs, tracking their growth or decline. They can measure water quality and detect pollution. Some are even being used to combat invasive species or clean up ocean plastics. Climate change is having a significant impact on our oceans. Underwater robots are crucial in studying these effects. They can monitor changes in water temperature and acidity over time. They can track the movement of marine species as they adapt to changing conditions. This data is vital for understanding the long-term impacts of climate change on marine ecosystems. Robots are also being used in more direct conservation efforts, like planting coral fragments and removing crown-of-thorns starfish. One exciting application is in combating illegal fishing. AUVs can patrol marine protected areas, detecting unauthorized vessels and gathering evidence of illegal activities. Underwater robots have profoundly changed our understanding of the oceans. They've allowed us to explore parts of the planet that were previously inaccessible. This has led to the discovery of new species and ecosystems. It's also changed our perception of how life can exist in extreme environments. These robots have also transformed how we conduct marine research. They can collect data more consistently and over longer periods than human divers. This has led to more comprehensive studies of ocean processes. From tracking marine migrations to monitoring deep-sea volcanoes, robots are providing unprecedented insights into ocean dynamics. Underwater robots have also had a significant impact on industries that operate in the marine environment, from offshore oil and gas to renewable energy and aquaculture. Perhaps most importantly, underwater robots are changing public perception of the oceans. The images and videos they capture bring the wonders of the deep sea to people around the world. This helps raise awareness of marine conservation issues. As we've explored in this essay, underwater robots are revolutionizing our understanding of the oceans. From ROVs tethered to ships to autonomous AUVs roaming the depths, these mechanical explorers are our eyes and hands beneath the waves. They've allowed us to discover new species, explore extreme environments, and uncover secrets of maritime history. The technology behind these robots is constantly evolving. Innovations in materials science, artificial intelligence, and power systems are making them more capable than ever. They're diving deeper, staying longer, and collecting more data than we ever thought possible. These robots are not just tools for scientific discovery, they're also becoming crucial for marine conservation efforts, helping us monitor the health of our oceans and track the impacts of climate change. As we continue to push the boundaries of this technology, we can look forward to even more amazing discoveries from the depths of our blue planet.